Hi, my name is Germán Moltó. I am Associate Professor at UPB, and in this video we're going to demonstrate how to deploy Galaxy in OneDock using the Infrastructure Manager. This is a research work part of the indigo-datacloud project. So basically what we're going to do is to deploy a TOSCA-compliant definition of a Galaxy node through the Infrastructure Manager on a OneDock testbed exposed via an OCCI server. And in case you are not familiar with these concepts, let me just introduce them a little bit. TOSCA is a standard to define application architectures for the cloud. And in this particular example, we're going to focus on the YAML specification of TOSCA. Galaxy is a web-based platform for data-intensive biomedical research, and it exposes a web frontend in which scientists can use it to perform their data-intensive simulations. The Infrastructure Manager is an open source tool to deploy and configure complex application architectures on multiple cloud and container-based backends. OneDock is a development made for OpenNebula in order to support Docker containers as if they were lightweight virtual machines. So you maintain the same APIs and the same graphical user interfaces and command line interfaces, and you can deploy Docker containers as if they were virtual machines. And OCCI is a standard to interact with cloud management frameworks. So basically we package our OCCI in a Docker container for easy distribution. So this is basically the overall picture of the demo that we are going to perform. First of all, the user is going to connect to the Infrastructure Manager in order to register the TOSCA document in which you describe the Galaxy node together with the requirements you want for the infrastructure. And this is represented currently as a TOSCA document, and we are using GitHub in order to store these documents, because this way we have versioning and we have the ability to retrieve these documents very easily. Then we're going to register the credentials used to access the cloud testbed. In particular, we're going to use a OneDock testbed. Then the user will deploy this TOSCA document in the OneDock testbed, and for that the Infrastructure Manager is in charge of provisioning the computing resources, which in this case is going to be a Docker container. And then the Infrastructure Manager is going to connect to that Docker container, and then it's going to perform some configuration actions in order to deploy the Galaxy portal. So basically we are going to configure dynamically deploy Docker containers. And notice that the communication from the IEM to the OneDock testbed is made via this OCCI component, which is going to be running as a Docker container itself in the OpenNebula frontend. This OneDock testbed will be composed of one OpenNebula frontend and 3 OpenNebula hosts. And finally, once you have the Docker container customized with the Galaxy application, then the user will access the Galaxy portal using a web interface. So this is basically the overall picture. So first of all, we're going to connect to the Infrastructure Manager, and for that, we are going to connect to the web interface of the Infrastructure Manager. And once we log in with our user and password, and we're going to try here to log in with our user and password. Then in this section, you will see that we have different recipes for infrastructure deployment. And in particular, we have here this TOSCA Galaxy node description. And this description comes from this repository, which is the indigo dc/TOSCA types. And here you will find different TOSCA-based examples, and in particular, we're going to use for this example this one, which is the Galaxy tosca.yaml. And you will see that this document has just been copied and pasted here, so we can see the document. And you will see that here we have this definition of this TOSCA document in which we describe this Galaxy node, which is of type tosca.nodes.indigo.galaxy portal. and we say that we need this LRMS, and this LRMS is of this type, and this requires a host which is called Galaxy Server, and Galaxy Server is of type TOSCA.nodes.indigo.compute, and we specify the requirements. We need a public IP, we need one CPU, we need 1 GB of RAM, and we need this certain Ubuntu distribution, which is Ubuntu 14.04. And finally, we have this output section in which we want to expose the endpoint in which the Galaxy portal will be listening. So this is basically a basic description, and for that we had to define or to extend the TOSCA standard with additional non-normative types. And if you are curious about these non-normative types, here you have this document. And in this document, if you look for TOSCA.nodes.indigo, you will find the different non-normative TOSCA types that we had to define in order to support the different capabilities for the applications in the Indigo project. So coming back here, what we're going to do is to focus on the credentials part. And here in the credentials section of the infrastructure manager, you register your credentials to access the different cloud platforms. So basically the IAM supports a wide range of cloud providers, either public cloud providers, on-premises cloud providers, and we also support OCCI in order to access, for example, the European grid infrastructure. And also we are able to deploy directly Docker containers and also support Kubernetes and other platforms as well. So basically in this list of credentials, what we have here is that we specify the endpoint of our OneDock testbed, and you will find here this endpoint. And notice that you need to have a valid FedCloud proxy certificate, and we already uploaded this proxy certificate here. So basically we define these OCCI credentials specifying the endpoint, and we uploaded our host certificate. Now we're going back to this section, and then we're going to choose the TOSCA Galaxy node, and then we're going to deploy this TOSCA Galaxy node, which is this TOSCA document. We're going to deploy it on this testbed. So if we go here in the infrastructures, we'll see that there's this infrastructure created when we perform the deployment, and the status is already pending. So we're going to connect directly to the OneDock testbed. You see the status now changed to configuring, but if we connect to the OneDock testbed, and here you will see the OpenNebula interface, then we go to the virtual machine section. Let me just connect again. And we go to the virtual machine section, you will see that a new virtual machine was deployed, and it is in state running, and it has both a private and a public IP, so it's accessible from the outside. Of course, we can connect via VNC. And if we connect via VNC, we will see that we have direct access to this Docker container, because this is an OpenNebula installation modified to support Docker containers, and this is basically provided by the OneDock project. And if you connect to the Indigo DC at GitHub, if you search for OneDock, you will find here this open source project to support Docker containers in OpenNebula. Now back to OpenNebula. You will see here the virtual machine running, and if we go to the infrastructure manager, we refresh, we will see that the Docker container is still configuring, and we can take a look at what's going on. We connect via VNC, we can execute top, and you will see there is some pip command here that is executing. And the thing is that the infrastructure manager has provisioned the Docker container, and it is connecting via SSH to the Docker container, and it's installing Ansible, it's installing a Zabbix agent for monitoring, and it's installing all the software components required to support the Galaxy application. It has to compile Galaxy, it has to retrieve the Galaxy portal, and it has to install all the required tools in order to support this information. Now let's go back to the infrastructure manager dashboard. And this takes some minutes. Now after some minutes, the infrastructure changes to status configure. And this means that the Docker container is already configured with the support for the application. Now you can know what went on during the configuration. And here you have a log of the things that were installed in the Docker container. But if you go directly here to this output section, you will directly have this information that, if you remember, you specified in the TOSCA document these output sections in which you stated you wanted to obtain the public IP and then the port in which the Galaxy portal was listening. So if you click on this link, then you will see the Galaxy portal running inside the Docker container, dynamically deployed on top of the OneDock testbed. So there you go. Now these things can be improved, because if you start from a pre-configured Docker image, then the installation is much faster, because you actually don't have to install lots of software. So in this particular example, we started from a fresh Ubuntu Docker image. So you had to install Galaxy, Zabbix, Ansible, but you can have all this software pre-staged in the Docker container. So this would allow to deploy infrastructures much faster. And remember, even though here in this section we're talking about virtual machines, it's not really a virtual machine, it's just a Docker container running. So basically this ends up this demo, and just to summarize, the infrastructure manager provides a graphical user interface, also an API, and also a command line interface for users to register their credentials and to access cloud management frameworks. So users can specify TOSCA documents to describe customized virtual infrastructure, and we also support the RADL native language for the infrastructure manager. This component manages the lifecycle of the virtual infrastructures and can interact with multiple cloud backends. So the user has a dashboard to deploy and manage their own customized virtual infrastructures. So if you want more information, go to www.cricap.upv.es/im. For a contact person, you have Miguel Caballero and Germán Molto from UPV. So thank you for listening.